Well, ahoy there, mateys. We are going to learn about greatest common factor. It's all about 1.4 this time around. So, common factors are factors or numbers that can be divided into two or more different numbers. Common factors are when those numbers are the same. So, that was kind of confusing. Rather than show you this video, I'm just going to jump right into some examples. So, like if I have the factors of 8, 1, 2, 4, and 8 are the factors of 8. Those are all the numbers that go into 8 evenly. The factors of 12, 1, 2, 3, 4, 6, and 12. The greatest common factor between those sets of numbers is 4. So 4 is the greatest common factor that goes into 8 and 12. So that's what this is all about. So here, let's jump right into how to find the greatest common factor, also known as the GCF. So sometimes it'll just say GCF because greatest common factor is kind of a pain to write out all the time. The easiest way to do this, no, not always the easiest, but the one that always works, sometimes is actually kind of a pain, is to list out all the factors. So like if you're trying to find the GCF of 24 and 40, you actually just have to list out all the factors. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Those are all the numbers that can be divided into 24. And then the factors of 40 are 1, 2, 4, 5, 8, 10, 20, and 40. So you look at your list and you find out what is the biggest number they have in common. There's the greatest common factor. So take a look at that list. What is it? Yeah, it's 8. So 8 is the biggest number that goes into both 24 and 40. This list method is very effective. It works really well. The only problem is sometimes you're going to make a mistake and you're going to miss. You might have forgotten. No, I forgot about 3 times 8 is 24. You might not even put 8 on your list, and then you would have gotten the answer wrong. So the list method is good. But the method that works all the time, once you really get at it, is the second method, which is using a factor tree to find the greatest common factor. So if you're trying to find the GCF of 12 and 56, you could list all the factors of 12 and list all the factors of 56, but the factors of 56 are not always that easy to figure out. Like, do you know off the top of your head that 28 goes into 56? Maybe not. Do you know that like 14 goes into 56? Not always doesn't always jump right into your head. So what you can do is a factor tree. So if you break down 12, that's 2 times 6. They should circle the 2. I don't know why they didn't circle the 2. Circle the 2. And then 6 can be broken down to 2 times 3. So the prime factorization of 12 is 2 times 2 times 3. And then you also break down 56. I'm not going to you can look at it and see how they did that. And then what you do is you list out your prime factors. So 12 is 2 times 2 times 3. 56 is 2 times 2 times 2 times 7. These red, they're supposed to be circled nicely. I don't know what happened there on that screen. But anyway, so they circled these 2's that they have in common and these 2's that they have in common. So they each have a factor of a 2. Not this 2, though, because this one doesn't have a third 2. So you only circle 2 of the 2's. You multiply the 2's together, you multiply the common factor, prime factors together, and that gives you the greatest common factor. In this case, it's 4. So they take the 2 here, multiply them together. You get 4 is the GCF of 12 and 56. All right, so that was a little tricky. Take a look at this. Make sure you understand it. Let's see if I can hide these little... hide? Yeah, it does. There it goes. Okay, so take a look at this. Make sure you understand it. Because now you're going to try this problem right here. So you can either do the list method or do the prime factorization method, but I want you to find the GCF of 40 and 48. It says using prime factorization, but you can do the list if you want. But do this on scratch paper and see what you get. Okay, now let's watch this little video where they walk you through how to do this using prime factorization. Okay, here we go. Hopefully the audio plays. Let's find out.
Find the GCF of 40 and 48 using prime factorization. First, make a factor tree for each number. One way to make a factor tree for 40 is as follows. 40 is equal to 5 times 8. 5 is prime, and 8 is composite, factoring into 2 times 4.
And if you still have questions about factor trees, just make sure to ask in class. We can go over some examples, or see Mrs. Root. She can help you out too.
2 is prime, and 4 is composite, factoring into 2 times 2. So here is one way to make a factor tree for 40. One way to make a factor tree for 48 is as follows. 48 is equal to 6 times 8. 6 is composite, factoring into 2 times 3, where both 2 and 3 are prime. And again, 8 is composite, factoring into 2 times 4, where 2 is prime, and 4 is composite, factoring into 2 times 2. So here is one way to make a factor tree for 48. Next, use the factor trees to write the prime factorization of each number. From the factor tree for 40, the prime factorization of 40 is equal to 2 times 2 times 2 times 5. And from the factor tree for 48, 48 is equal to 2 times 2 times 2 times 2 times 3. Next, circle the common prime factors.
So how many 2's are they going to circle here?
There are 3 common prime factors of 2. Next, find the product of the common prime factors, and this is the GCF. 2 times 2 times 2 is equal to 4 times 2, which is equal to 8. So, the GCF of 40 and 48 is 8.
All right, how'd you do on that one? It is indeed 8. There you go. All right, you could have also figured that out with the list, as long as you remember that 8 goes into both of those numbers and included it in your list. Okay, we have another set of examples here. So your job is to figure out which of these pairs of numbers has a GCF of 12. So however you need to do it, figure out which of these sets of numbers has a greatest common factor of 12. Okay, so 12 doesn't go into 18, so it is not A. 12 doesn't go into 30 either. So 12 is not a factor of either of these in A. For C, 36 goes into both of these numbers. 36 is the greatest common factor for C. For D, 12 goes into 48, but 12 doesn't go into 54. So 12 is not a factor of 54, therefore it can't be the greatest common factor. Leaving B. So 12 goes into 24 2 times, 12 goes into 36 3 times, therefore 12 is the GCF of B, 24 and 36. All right, and then sometimes you'll have some word problems that require GCF. So, and they often look like this. So you're making appetizer platters for a party. There are 16 fruit kebabs, delicious, 32 cheese cubes, and 40 meatballs to put on the platters. You want identical groups of appetizers on each platter with no appetizers left over. What's the greatest number of platters you can make? So in this problem, you're asked to find the GCF. So basically, you're going to divide up all these different types of things you're going to put on the platters into a set amount of platters. That is the GCF. All right, so see if you can solve. What is the GCF for this problem? All right, so 8 goes into 16 and 32 and 40. So 8 is the biggest factor that goes into all three of these. Therefore, you can make 8 equal platters using those items. There you go. All right, so that is GCF. Again, if you have questions while you're working through big ideas, make sure to ask. And if you need to rewatch this video, or if you need further instruction on GCF, make sure to let me know and I will hook you up with some stuff. All right, good luck, pirates. I'll see you in class.